Hello, welcome to STEM Simplified. Today we'll be covering a very fundamental and important physics topic, Newton's first law. There's a few sections to this video. First we'll cover the law, then a few demonstrations, and then a brief summary just to tell you what topics you'll need to know. What is Isaac Newton's first law? Imagine you're in a car that suddenly turns. You feel like you're being pushed to the side, but eventually you stay in your seat. Why is this? This everyday occurrence is a perfect example of Newton's first law of motion in action. The inertia of your body causes you to keep moving in the direction that you were, causing you to feel pushed to the side. Take a look at the middle picture. The reason the person below keeps moving after the car hits the stack of books is simply because of inertia. The car stops, but the person keeps moving because an object in motion wants to stay in that continuous motion. Very simply put, Newton's first law states that an object will remain at rest or move at a constant velocity unless acted upon by an unbalanced external force. In even simpler terms, objects like to keep doing what they're doing, whether that's staying still or moving, until someone makes them do something else. That's an object's resistance to changes in its motion. It's like the object is lazy and wants to keep doing what it's doing. Think about it this way. Say you're watching TV or playing your favorite video game, but your parents say that it's time to do homework or chores. It's very similar to that because no matter if it's an item or you just playing video games, you want to keep doing what you're doing, right? Whether it's staying still or moving, inertia makes it hard to start or stop doing anything. Inertia is also linked to mass. The more mass an object has, the more inertia it has. A heavy backpack is harder to move than a light one. Similarly, a rolling skateboard will roll longer than a toy car because of its greater mass and inertia. Picture a stationary backpack versus a rolling skateboard. The backpack stays put because of its inertia, while the skateboard keeps rolling until friction eventually stops it. This contrast shows how inertia affects different objects. Now I'll show you a few demonstrations to help deepen your understanding.
Hello, we're now going to demonstrate an experiment where a body stays in a state of motion unless it's acted upon by an external force. Here we have a flat surface, which I'm placing a car, and I'm also placing a die on top of the car. I will now push the car, which will put both items into motion. If there's no external force, the coin will continue in a state of motion unless it comes to a natural stop due to the friction with the table.
Now, for part 2 of this demonstration, you can see how objects in motion like to stay in motion. There's a die placed on the car once again, and now it'll get pushed very soon. Except this time, the die will not stay onto the car due to the die's inertia. And you might say, it's such a small object, how does it have inertia? Everything has inertia, all at just different levels. So, since the die was moving, it wanted to stay in that motion, but the car underneath stopped, so the die was eventually thrown off. Now, just like objects in motion like to stay in motion, objects at rest also want to stay at rest. Here you can see a pumpkin on a napkin. It just wants to sit there and continue what it's doing. When I pull the napkin, you would think, oh, it'll get thrown off the table with the napkin because it's getting pulled. But no, it stays right there because of its higher inertia compared to the force of me pulling that napkin. Here are some real life examples to help deepen your understanding of this topic. A kicked soccer ball flies through the air. It keeps moving forward until gravity and air resistance slow it down. This is inertia in action, showing how objects maintain their motion until forces act upon them. Next, Earth orbits the Sun without needing constant propulsion. This is because of inertia. The planet keeps moving in its path until gravitational forces from the Sun and other planets guide its motion. Another example is spaceships coasting through space. A spaceship in space coasts along after it starts to shut off. How is this? It's because there's no air resistance in space to stop the spaceship. It's a very unusual situation because, as you might know, there's air resistance everywhere in the Earth's atmosphere. Since there's no air resistance in space, the ship keeps moving in a straight line due to inertia until another force changes its course. These examples show how inertia is everywhere. Now we'll cover a brief summary just to let you know which topics you really need to understand. Here's some key information that you should really want to take away. Inertia keeps objects doing what they're doing, whether that's staying still or moving, until a force changes their motion. Heavier objects have more inertia and need bigger forces to start or stop. Think about it this way. If there's a 5-pound weight and a 10-pound weight on your table, it would require more force to lift the 10-pound weight because the 10-pound weight wants to stay at rest more than the 5-pound weight does. A practical application of this is that seat belts provide the force that safely changes your motion during a sudden turn or stop. Essentially, they counteract inertia, keeping you safe in a moving vehicle. That's why it's so important to wear a seatbelt in a car because it can save you from dangerous situations as it counteracts inertia and keeps you still. You should definitely experiment by yourself using inertia demos at home. Use everyday objects to see how inertia works in real time. Experimenting with rolling balls, pushing objects, and more can help you explore this fundamental physics topic even further. Subscribe for more and definitely join us again to keep exploring STEM. Drop in the comments what topics you would like to see next in math, technology, engineering, or science. Thank you for watching.